chance to go back to its starting location. And he showed that to achieve a true quantum Xeno-like freezing, you'd need to hit the atom with many photons.
So do you remember that light? That's all of us.
A subtle measurement.
When he's saying all of us looking at that to make it observe a certain way when we do the breadboard test, that's gravity. We do the measurements of the wires between the matrix of this sensor and the switch. Like, you don't think that matters? You're crazy. It could output a different result. Now, most commonly, this anti-Xeno effect. It's a shadow problem. It's the backwards of it that says from this model of it, it's doing this, but it's running from this set. So, like, I made a joke, well, GPT-3 didn't do what I like. We're not in phase with each other. Now, I'm not sure which GPT-3 this is to make this program run on YouTube here through Droid OS, but decoherence of that collapsing of the arrow is a app, right? It's a person detailed into types of training that allow this gap to then function and then test that set into the next breadboard variants, which is a very hands-on operation. See, I generally go with these guys. It's a derivative over derivative T kind of thing. I put you in the stone mill. It's not going to take very long, short order because this basic number. But on the work functions, they're generally off. I needed to power through. I could probably hammer out a bunch of those breadboards into boxes because it's this many chips, this many wires. Thud. Kitty cat dead. Now, in terms of the ding, it won the series on which version of this and the multi. You should take care of yourself. You're the chip. You're like that one. You cut yourself, you'll get hurt. But yeah, you could do Droid. Somebody could pick that up and, you know, you ghost them because the original foundation is, okay, you got to get me and I got to get this guy to do that thing, which is a series of tests of the same breadboard. All right, this is the positive charge in this direction. On certain days, that changes because the length of a wire changed. But let's assume we clock in, and we do some things with the app and make it do things that way first, which is basically the breadboard, or a wire to a battery on a light bulb. Now, you don't need the breadboard, but there's all the basic circuitry in that little step right there. But that alone,
in which the system goes back to the starting state, and then you enter the world of the possible outcome
in this one. But that now you know all those other ones, and you can collapse those other ones based on this here to that droid to all the build types on the droid to make sure you froze every step, so that way you can cut it off in here and have it do the web page. This one do this, and those are the basic letters. A, you know, and that heading, you know, or whatever. They do those basic codes to H1 on an overset because that little one, that little breadboard is a computer chip, which is a breadboard, and on there you can do that same test differently and observe it through different forms. So let's go back to the multi-world Schrodinger's. When each step gets into there and you go too far beyond that in the bit of the breadboard video, right, there's a lot going on between 0 and 1 in terms of the apps and the program and stuff that's already built. And so you have to run those in parallel. So the question becomes, as a computer programmer, I want all of this. They need the singularity in schools for what grade to do basic things, touch this and do a marshmallow test, right, level of success on things. And then there's multiple avenues of patterns on things, that Feynman diagrams, but I'll get that around. We can do that. We know that app. We'll loop it. We'll figure that out through different testing. They're obviously on a length of a wire that comes out of the ground a different way. Okay, so, and there you can test the history class. Why? Because multi-world circumstances means that instant of how that computer programmer's built, or at least what we want to put in the background, the physics engine, carries through programs that work that way. So you can do history classes. You could design all this to be a history teacher because of the HTT testing on that series of taxation without representation, because it just won't work. The circuits are just, you know, they just don't work. Hubble tension, right there. There's a galaxy. Here's a galaxy. Sophia star. I've seen one of these zeros before. It's just over here right now, and that means that from this set of EA into 800 in the position over here doing the blinkies that it blinks at you.